Chapter 5, Example 3. Many colleges and universities require applicants to submit scores on standardized tests, such as the SAT writing, math, and critical reading, verbal tests. The college your little sister wants to apply to says that while there is no minimum score required, the middle 50% of their students have combined SAT scores between 1530 and 1850. You'd feel confident if you knew her score was in their top 50%. But unfortunately, she took the ACT, an alternative standardized test. The college doesn't report the mean or standard deviation for their applicants on either test, so we'll use the group of all test takers nationally. For college-bound seniors, the average combined SAT score is about 1,500, and the standard deviation is about 250 points. For the same group, the ACT average is 20.8, with a standard deviation of 4.8. How high does her ACT score need to be to make it into the top quarter of equivalent SAT scores? So we're going to be doing some Z-scores here. We want to do some calculations with the SAT score, and then the same with ACT. The first thing we always need to do is check that the normal model is appropriate. Always check that. Always have it stated in your answer. Though it is not stated that the ACT follows a normal distribution, standardized tests are generally designed to do so. We will assume the distribution of ACT scores is approximately normal. It is okay to proceed. Always check. In this case, we don't have the evidence. We'd like to see a histogram that's unimodal and symmetric really to tell if it's normal. We're not given that. We're not told it's normal. But the way standardized tests are designed, it's fair to assume that. So we need to state that. Now let's figure this out. 1530 to 1850 is the middle 50%, which means 1530 is Q1 and 1850 is Q3. So the top 25% of scores have an SAT score above 1850. SAT will be 1850 minus 1500 over 250, which equals 1.4. That's our Z-score for the SAT top score. Now let's find what that compares to in the ACT. We still want a Z-score of 1.4. So I'm going to have X, which would be the score that your sister needs to get on the ACT score to have an equivalent of 1850. So X minus 20.8 over 4.8 would equal 1.4. So if you're in the top 25% of SAT scores, your Z-score will be the exact same for the top 25% of ACT score because they follow the same model. So we multiply both sides by the 4.8. I get X minus 20.8 equals 1.4 times 4.8. Now I want to get X alone, so I'm going to add that 20.8 to the other side. So X equals 6.72. I just did that multiplication there. Plus 20.8. X will be 27.52. To be in the top 25% of applicant scores, your sister would need an ACT score of 27.52. Remember, our question was how high does her ACT score need to be to make it in the top quarter of equivalent SAT scores? So that's all we're doing is finding that top 25%. We just had to understand that the middle 50% means we're going from Q1 to Q3, and then we can use our Z-score formula to evaluate this. There's going to be tons of different ways that you can see this, that we can write these problems. I can't possibly show you every example you'll encounter. But understanding how the Z-score works, what each component is, will allow you to synthesize your own solutions, to problem solve and figure it out. Understand that to calculate a Z-score, we do our data point, or our score that we want to know, so on, minus the mean divided by standard deviation. And that equals a Z-score. If we know the Z-score, we know the mean, the standard deviation, we can find the data value. If we know a data value, standard deviation, and the Z-score will give us, we can find the mean, and so on. So as long as we know 3 of those values, we can find the missing one.